I've got a list of rules here that will help when you're beginning to draw Lewis dot structures. Try not to get overly focused on always following the steps in this list, and trying to cross them off. Definitely use them the first few times, but you want to move on and hopefully just get used to the process of it so that it's much faster than having to read the rules every time. But I'm going to demonstrate the rules, each step of them, while I'm drawing this molecule right here, the CF4. So the first step is to add up the total number of valence electrons. Now you have already done that for this molecule. So it was carbon had 4, fluorine had 7. There were 4 of them. So when you add that up, you get your 32. And I always like to put a big old box around it. And just as a reminder, if it's negative, you have to add in electrons. And if this had a charge. Add in electrons if it's negative, take them away if it's positive. You can go review cations and anions if you don't remember that. Then you write down the least electronegative element as the center. So if you're looking at a periodic chart, so those are our first 2 tall columns, there's all our other tall columns, hydrogen, helium. So the most electronegative is over here, and that's what we don't want in the center, if possible. And then going in this direction is what's going to be in the center. So whoever's the most. So like in this case, carbon is like here and fluorine is like there. There's slightly, but anyways, the carbon is more to the left. So that is the least electronegative. That's going to be the center. Now, a general great rule of thumb is the first one is the one that goes in the center. Doesn't always work though, but that's a good rule of thumb if you're confused and you can't remember how to figure out the electronegatives. But anything that's away from this corner is going to be less electronegative. You can also call this electroaffinitive. Those are all in the same categories. Also, there are some elements that have hydrogen written first, like that. So hydrogen can't ever be the center. So why not? Because remember, hydrogen can only have 2 electrons. A bond is made up of 2 electrons. So that's 1 bond. So if you are only allowed to make 1 bond, you can't ever be in the middle of something because there's only 1 bond. You can't be in the middle if you've only got 1 bond. All right, so we have carbon written down. All right, the others around it, evenly spaced. So I have fluorines. I'm going to just put the fluorines around it, nice and evenly spaced. And you're going to draw lines from the center element. This represents bonds. There are 2 electrons in every line, every single bond. There are such things as double bonds. Just as a note, that wouldn't have a double bond, but you can draw double bonds, and that just means that there's a total of 4 electrons between these 2 elements. But it wouldn't be able to do that. We'll explain that in just a second. So that represents bonds. Then we're going to give the outer elements an octet of 8 by adding electron pairs and counting as we go. So right now, this one has a total of 2. Same for this one. There's 2 in there, there's 2 in there, and there's 2 in there. So these are the real number of electrons for this. 8 of them are already type in bonds, just saying. And so that means that we have 24 left that we can do something with that aren't in the bonds. So we're going to put electrons around the outside. We put them in pairs. Remember, if it was hydrogen only has 2. They're already tied up in the bond, so hydrogen wouldn't have these extra dots, but everything else should. And then if we're going to count these, we'll say that we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So I have the correct number of valence electrons. I've used everything up. So that's one way to do the counting. Another way that I like to count these, because sometimes when I'm counting by pairs, I don't know why, but I will skip count something. So again, everything except for hydrogen will need to be at 8. So if I'm sure that that's at 8, or this is a good check, 8, 8, 8, and 8. So if I'm sure about that, I can just say, okay, so that's 8 times 4 areas. So I've got 32 totally tied up, which matches with what I need. So I find that helpful too. Just however counting. I mean, if you find out that when you're counting, you are making a mistake with your counting, then don't count that way and find another way to count. Last but not least, check that the electrons around the central atom, count them and make sure that there are only 8 if these are the central ones. Remember, if you are in the third row or below, you could have more than 8, so those need to at least have 8, but these ones have to have 8. So again, as I count it, if I'm counting my regions, I've got 1, 2, 3, 4 bonds, which remember there's 2 electrons in each bond. So that's 8 electrons. Or I can count as 2s, 2, 4, 6, 8. Just make sure you don't leave them there as dots because they shouldn't be dots, they should be lines. So I'm good to go with that atom. One last little tip though, let me give you an example of something where I really do have to put some dots in to make it work right. So I'm going to do an example with PH3. Phosphorus has 5 electrons, hydrogen has 1, and there are 3 of them. So this has 8. When I draw PH3, let me scooch this up. Remember, hydrogen can't be in the middle. So the P goes in the middle, and then I'm going to put my H's in. So I've done this step, the valence count. I've written down the P in the middle because the hydrogen can't be in the middle. I've written the atoms around and drawn the lines. Now I need to give the outer ones an octet of 8. But since I have all hydrogens, they're already full. I don't put anything around the hydrogens. So he's got two right there, and he's good. This one has 2. This one has 2. So they're all good. So when you have hydrogens on the outside, you don't have to worry about making the octet. And then I have to count the electrons around the central atom to verify. So as I'm looking at this, you will notice that I only have 2, 4, 6 electrons around here. So this phosphorus is not okay. And you'll also notice something else is that my count here is 8. And remember what it says to do right here is that if there are extra electrons, put them on the central atom. So I had some extra electrons. I only used up 2, 4, 6 of them. So that extra pair, you just throw them on that middle atom. And that's what you always do when you have extra electrons. You put them on and put them on like a pair, a little grouped pair. And if, let's say you had 2 pairs of extra electrons, you actually kind of, they don't like to be near each other. And once you get into shapes, you'll see why they do this. But generally, we'll kind of group them together. We don't try to make them all opposite. So that's an example of how to deal with a structure that needs to have lone pairs on the middle atom.